Hi, as I said, I'm Lynn McGregor. I'm an innovation lead in the high-value manufacturing team of Innovate UK. As he said, my director was originally scheduled to give this talk, but he was unable to make it. So you won't see Simon Edmonds, a tall, silver-haired gentleman with a Welsh accent. But as I've actually led the team working on digital manufacturing in Innovate UK, you will see the whole picture. So Jürgen Meyer this morning mentioned about the fourth industrial revolution and what it means. I quite like this definition from iScoop, because basically it's saying that digital Industry 4.0 is the digital transformation of manufacturing. It says that this is leveraged or enabled by digital tools, but the key thing is that it's not the tools themselves, it's actually what you can do with those tools. And it's really important to understand your operations and understand how you're going to use these tools to make them different. So as it mentions, you were looking at connected factories and smart decentralized manufacturing and smart supply chains. And that's the important thing to aim for and use the digital tools. So a number of studies have been done showing how the fourth industrial revolution can provide the required improvements that we need to the UK economy. The British Consulting Group looked at the growth rates and the improvements in productivity that can happen, and EEF, and we've got an EEF speaker on later on, shows that it's going to make a really big difference to the UK in terms of making smarter supply chains, smarter production and smarter products. And Jürgen Meyer has led this industrial digitization review, which looked at, identified and quantified the gains that we can gain by using industrial digitized tools. So I thought that it might be useful to have a look at some of these digital technologies and see how they actually provide these gains that we're talking about. And I thought it would be worthwhile looking at virtual reality, augmented reality, digital twins, and 3D design and printing. Because these tools will have a far-reaching effect. They'll change how we design, produce, maintain, and recycle our products. Very much importantly, they'll change the way we do our new business models. They'll change the way we do business. And they're going to change the way our supply chain works, enabling us to maximize the benefits through all the strengths in the supply chain. Oops, too many bounces there. So virtual reality. Virtual reality is a computer-generated scenario that simulates a realistic experience. I want to imagine most of you have seen or tried those headset glasses in which you look into a virtual world. If you haven't, please do go to our exhibition stand, because we've got one on display there you can try. Augmented reality is different in that you're looking at the real world, but we then put in computer-generated information that allows you to understand more about that real world. Now, AR and VR are being used now by a number of big companies to get benefits, and we've mentioned Siemens here, so we've actually got a video on our exhibition screen showing an application that AMRC did with Siemens to develop a virtual reality digital twin. And Siemens say that this has been a real game changer for them, and they now look to use VR in every facet of their operations. Similarly, Rolls-Royce now use virtual reality in all of their key divisions, and they use it across the whole board, from design to training to customer interactions. And now they're looking to pilot augmented reality and all of that product life cycle in their key divisions as well. Now, digital twin is a new buzzword, and you're probably hearing lots of people talking about digital twins. Digital twins is essentially, it's a living model of a physical asset or a system, and it's constantly adapting to what's going on in the environment, and then you can use that to deliver the best outcomes. Now, the most important thing is that the essential ingredients to this is, first and foremost, a good model of that physical system or asset. And it's got to be quite a good model. It's got to be predictive, because it's very important that it comes up with the right numbers. And then it's really important you need to collect real-time data about that system or aspect. And you can do that using some sensors and IoT, etc. And then you need to collate that data and synchronize it to the model so that it knows what's going on at any one time. And then the model can take that information in, and then you run the model, and then you can use the output from that model to predict what's going to happen in the future. So it's really all about prediction, and it's about saying that because I know what's happening right now, I can predict what the future is, and it's very, very powerful. So all digital sectors, all industrial sectors will be able to benefit from the adoption of this. Gartner and IDC, well, they may have slight disagreements about the numbers, but both of them figure that this is going to grow rapidly and is going to have huge benefits. And certainly at Innovate UK, we're already seeing quite a lot of funding requests for digital twin projects. 3D design. 3D design and computer-aided simulation has been around for a very long time. But of course now with the increase in computer size and speed, there's an awful lot more that it can do. I've got to give an example here of Jaguar Land Rover, who used simulation and design to test all of their new designs. There's a picture here of them using, designing the dynamics and the ride dynamics of a Range Rover. So they do this to come up with personalize a Range Rover so you get a silky smooth ride with a Range Rover, or they can design a firm and robust ride for a Land Rover Discovery. And they do that all through simulation. And of course, once you've got a 3D model that has all of that information in it, you can then use it for training and maintenance with VR. And of course, you can also use it for your digital twin. And having a 3D model also can enable you to take that information and send it to a 3D printer as instructions to produce a part. And 3D printing, or additive manufacturing, is a really transformational cross-sector technology, and it's really having a big disruptive effect. Gartner is saying that there's going to be quite a high growth rate, 27% annual growth rate from a couple of years ago into the future. And an industry-led group, Additive Manufacturing UK, has had a look at this and tried to identify what are the opportunities for the UK in additive manufacturing. And they are huge. They're really very, very substantial. But there are challenges that we need to address in order to achieve that. So those are the different technologies that can enable these huge gains that we're talking about through the fourth industrial revolution. But the thing is, so what's Innovate UK doing about it? Well, Innovate UK, we aim to drive productivity and growth by supporting businesses to realize the potential of these new technologies, and we want to make them a commercial success. So we fund projects and we do a lot of work in order to encourage and support innovation in these areas. We started in 2007, and since then we have invested 2.2 billion in research and development projects. And then along with industry match funding, that totals 3.75 billion in this. And through that, we've managed to fund over 8,000 businesses. And each of those 8,000 businesses has generated an average of 8 jobs. And so altogether, we've been able to create about £7.30 back to the UK economy through our investments. So I just wanted to share a few of the projects that we have funded and how we go about doing this. So between 2014 and 16, we had focused competitions that looked at specific areas, and so there were 3 that were targeted at these fourth industrial revolution technologies. In the automation for manufacturing competition, we funded a project called Augmented Manufacturing Reality, and the picture on the right is that augmented reality. And that basically did 2 things. One, it identified applications both in Ford and also an elevator lift servicing company, and it developed software and apps for this augmented reality. There was another, the virtual engineer, which is looking at coming up with predictive models to enable you to do predictive maintenance and diagnostics. Then the flexible manufacturing competition was all about looking at how to use these technologies to really make a difference in business models. So it was very much focused on changing the business models. 2 that I'm mentioning here. So one was looking at remanufacturing rail components, or rail wheels. And that looked to change the supply chain, the way they actually did changes in fixing rail cars, and this is mainly for underground trains and everything. So it changed the way they did the whole supply chain and also increased the speed and reduced the cost of doing that. Another one was looking at a new chemical process that enabled continuous operation. And the way that it did it also enabled the company to look at distributed manufacturing across the world, because they could now have operations going on which they could have remote information about, and they can manufacture where they wanted instead of one large batch operation. The towards zero prototypes is looking at using simulation and modeling to model, so you don't have to have prototypes, so you can model in virtual space. And there were a number of very interesting ones. So one was looking at photorealistic imaging of garments, of fashion, in order to design and sell these garments before anything was ever made. There was another one, so the picture of an airplane there. So we also funded a project looking at modeling complex flow and turbulence. And then finally there was one for a digital twin for a factory layout and operation. And this project was done by Lanner, who provide Witness, a discrete event simulation software, along with GE and the University of Cranfield. Now, that should be being displayed on our exhibition stand. Unfortunately, he had delays in getting here because of the snow, but hopefully he'll get here at some point. And then, since then, we've done sector competitions. And of course, we still funded a number of projects in this space, in those sector competitions. In the manufacturing materials round one, we funded a project for looking at servitization of manufacturing machines. And again, that one is out in our exhibition stand. MTT are showing how they're using sensors and diagnosis to produce a servitization model. Also, we've looked at ergonomic real-time assessment, and in manufacturing materials round two, there's a couple, so cooperative model predictive control by Spiro Controls. This company is also out there in the exhibition stand, this time in the KTN showcase, if you're interested. And on our stand, we have Mastering Industrial Network Dynamics, which has a new way of looking at supply chains. And we've also looked to fund, both in our focus set competitions and then later in our sector competitions, a wide range of additive manufacturing projects. So in the time from 2016, we've funded 40 additive manufacturing projects from those calls of a total value of 25 million project cost. And there's one in our exhibition stand by Limit State, looking at, they've got some 3D printed models that they've come from an anvil project. Actually, let's go back there. So one of the things I'd like to highlight is the kinds of projects we fund. They do two things. So we always try to make sure that we include SMEs, because it's really important to make sure that SMEs understand this kind of technology, use it to grow. But so we quite often fund SMEs. Sometimes they're either using the technology, or sometimes they're developing technologies and software for the use of in the fourth industrial revolution. And so these projects tend to do two things. They both develop the technologies that we want to use coming up, and they develop applications to show how these technologies are going to be used. And I think that's quite critical, in that we need to have both. We need to see how the things are going to work in actual applications, as well as developing the technologies. So we do more than just fund technology projects. We also create and fund catapult centres. And these catapult centres, there's 7 high-value manufacturing catapult centres around the UK, and these are places where you can go to test and de-risk your applications. And you haven't known about them You should try them. Again, we've got a section of our stand that shows the high-value manufacturing catapult centres. And we also fund and support initiatives. So Immerse UK is an initiative that looks to help UK businesses to take full advantage of new AR and VR opportunities. And For Manufacturing is an initiative by the KTN looking to help SMEs, and there's more about that in tomorrow's session. And then with the KTN and the EEN, we also connect up customers, suppliers and partners both nationally and internationally. And now there's even more that we can do to support Industry 4.0, because now with the industrial strategy, this has opened up a lot of extra opportunities for us. In particular, the government had pledged substantial amounts of money for science, research and innovation in the form of the Industrial Strategy Challenge Fund. The Wave 1 of the Industrial Strategy Challenge Fund funded 8 challenges: manufacturing materials technologies, robots for a safer world, batteries for clean and flexible energy storage, or the Faraday Challenge as it's called, and also projects looking at self-driving vehicles, manufacturing materials of the future, and satellites and space technology. We just recently announced the second wave of the Industrial Strategy Fund, Challenge Fund, and these 8 challenges, most of them are actually using digital technologies as a way of addressing the challenges that they're looking at. And that's not all. There's a lot more things coming up within the Industrial Strategy Challenge Fund. Jürgen Meyer this morning mentioned that Greg Clark had announced that the Made Smarter Commission. He also announced that we would be working together with the Made Smarter Commission to look to fund and support this industry sector deal. And not only that, in November, the government announced that we will be holding a third wave, a call for challenges for the third wave of the Industrial Strategy Fund, looking at an expression of interest for potential challenges. I'm happy to say that today is the day. The expression of interest is now open on our website. You can go to our website, to the Innovation Funding Service, and have a look at what we want. This ELI process is going to enable industry to fully engage with the Industrial Strategy Challenge Fund, and we hope to bring in those businesses and sectors that don't traditionally make use of innovation funding. And we hope that this will bring an opportunity to identify some real novel or transformative challenges that we might have missed otherwise. So this expression of interest is now open. I can't give much more details about this now, but if you'd like to know more, please come to our exhibition stand where I or some of my colleagues can tell you more about it. So to wrap up, we're always looking to support the developing industries of tomorrow, because that's our role, is how do we get there? How do we address tomorrow?
Thank you. Thank you. Thank you very much.